Hello, my dear children. Today we are going to discuss about the sums in exercise 1.2 in the number systems. Okay, my dear children. Now come to the question number 1. State whether the following statements are true or false. We have to check whether the given statements are true or false. Justify your answer. After verifying the given statements, whether it is true or false, we have to give the reason also. Understood the question, my dear children? Right. Come to the question number 1. First statement. Every irrational number is a real number. It is a given statement. Is it a true statement or false statement? Yes, it is a true statement. Come to the solution part. It is a true statement because the collection of all real numbers, the collection of real numbers is made up of rational and irrational numbers. Okay, my dear children. In a real numbers, all the rational numbers will be there and all irrational numbers also will be there. So every rational number is a real number. Similarly, every irrational number is also a real number. But converse need not be true. Understood, my dear children? Right. Now come to the second statement. Every point on the number line is the form root m, where m is a rational number. This is a given statement. Is it a true statement? No, it is a false statement because no negative number can be the square root of any natural number. Square root of any natural number cannot be a negative number. But on the number line, negative numbers also there. So every point on the number line may not be in the form square root m. Understood, my dear children? Right. Now come to the third statement. Every real number is an irrational number. This is a given statement. Is it a true statement? No, it is a false statement. It is just like converse of the first statement. Every real number is not irrational number, but every irrational number is a real number. At that time, I told you. So here it is a converse of the first statement. It is a false statement because one is a real number, one is a real number, but it is not a irrational number. Every real number may not be irrational number. It may be a rational number or it may be an irrational number. Understood, my dear children? Right. Now come to the question number 2 in this exercise. Are the square roots of all positive integers irrational? This is a statement. Are the square root of all positive integers irrational numbers? If not, give an example of the square root of a number that is a rational number. Understood the question, my dear children? Right. So here the square root of all positive integers may not be irrational number. So we wrote here no. For example, see these examples. 1 is a positive integer. Square root of 1, 1 only. 4 is a positive integer. Square root of 4 is 2. It is a rational number. It is not an irrational number. 9 is a positive integer. Square root of 9, 3. It is a rational number. It is not an irrational number. Similarly, 16 is a positive integer. Square root of 16 is equal to 4. 4 is a rational number. It is not an irrational number, and so on. So these are all rational numbers only. So positive square root of positive integers always may not be an irrational number. They may be rational numbers. Understood, my dear children?
Right.
Right. See the next question, my dear children. Here you have to construct, you have to show root 5 on the number line. We have to represent root 5 on the number line. To represent root 5 on the number line, first of all, draw a ray AX. Draw a ray AX. That is the step 1. Step 1. That is step 1. Draw a ray AX. Draw a ray AX. Next, step 2. Step 2. Observe these steps, my dear children. Take some radius as your wish. You can take 2 centimeters as radius, 3 centimeters as radius, or 4 centimeters as radius. As your wish, take compasses and radius as your wish, 2 centimeters or 3 centimeters or 4 centimeters as your wish. And take A as center, A as center, cut the ray AX, cut the ray AX. Here you get to some point. Again take another, take this point as center with the same radius. Don't disturb the radius. Again take the same radius, cut the AX ray. Here we cut the AX ray at 2 points. Namely here P, let us consider it is B. At P and at B we cut the AX ray. Now here takes A as center, take A as a center, with a convenient radius, cut AX, cut AX at P. Again take P as center, take P as a center, the same radius, same radius. With the same radius, cut AX ray at B. Understood these steps, my dear children? First of all, we have drawn a ray AX. Okay, my dear children. After that, step 2, take A as a center, take A as center with some convenient radius. With some convenient, radius. I told you, you can take 2 centimeters or 3 centimeters or 4 centimeters as your wish. With your convenient radius, cut AX at P. Okay, again take P as a center with the same radius. Again cut the AX ray at B. We got here point B. Understood, my dear children? Right. Now Step 3. Step 3. With the help of protractor, construct angle with the help of protractor. Construct angle ABY like this with the help of, not with the scale, with the help of protractor. With the help of protractor, construct here right angle. Understood by the children? Right. Now step 4. Now take B as center. Take B as center. Take B as center. It is the previous radius, same radius throughout this question. Don't disturb the radius. The same radius. The same radius. Cut B by ray. Cut B by ray at C. Now take B as center with the same radius. Cut B by ray at point C. Understood, my dear children? Now join AC with the help of ruler. With the help of ruler, join AC. Join AC. Step 5. Join the points A and C. Then the length of AC is nothing but root 5. Then AC length. Then AC length is root 5 units. Because see here, we have taken AB is equal to 2 units. And BC is equal to 1 unit. In triangle, we have taken like this 2 units. It may be 6 centimeters or 5 centimeters or maybe anything. Here BC length is 1 unit. Then by the Pythagoras theorem, we get here, what do you get here? By the Pythagoras theorem, AC square is equal to AB square plus BC square. This implies AC square is equal to AB square plus BC square, 1 unit. This implies AC square is equal to 4 plus 1. This implies AC square is equal to 5. Okay, my children. Then AC is equal to square root of 5 units. So this is the length of AC. Understood, my dear children? Now on the number line, now draw number line here. Finally, draw number line here. Here, take the same radius, previous radius, cut like this. Here 1, again take this point as center, cut here 2 with the same radius, cut like this. So these are 1 unit. On this number line, understood by the children? AP, take a radius AP and take over center, cut here, and take the same point, radius is same, cut here. Again take this point as center and with the radius same, cut there. Understood, my dear children? Now take AC as radius. Take AC as radius. Keep here pointer of the compasses. Take here. Then cut this cut the number line here. Cut this number line. Let us consider this is M. So OM is equal to root 5 units. Understood, my dear children? This is a procedure to represent root 5 on the number line. Okay, my dear children? Right.